Okay, this is my video for the open-ended questions for test 4. I'm going to try to be quicker than I normally am. It usually takes me a long time. Anyways, okay, so the first question is the swimming question. Part A is basically asking how much energy is expended, how much energy is used in a 50-meter race. So what I found was using the energy produced equation, which is just energy equals power times time. So applying that, we'll do 800 times 22, which is 17,600 joules. I can show you on the calculator. So yeah, 17,600 joules. So to begin with, but to find that energy expended, we'll multiply that times 0.25. So that is 4,400 joules. For part B, it is asking what the energy is that it's used in arm motion, and if half the energy is used in arm motion and half in leg motion, what is the energy expenditure per arm stroke? Okay, so we know we've got the 17,600 joules. And let's see. So if we divide if we divide the energy in half, obviously half of 17,600 is 8,800 joules. And if we're finding that per arm stroke, we'll divide 8,800 by 30. So that's like 293 joules per arm stroke-ish. For the second question, about the ice cube, just reading the problem. Ice cube at 0 degrees Celsius. How thick of a layer of ethyl alcohol must be poured on the water so that the top of the set that is flushed with alcohol? Show your answer in milliliters, and then it gives us the density of ice and of the ethyl alcohol. So write down what we've got: the density of ice and density of ethyl alcohol. So first off, I'll find that mass. So times 0.7. Okay. Sorry, let me just refer back to find my spot in my notes. Okay, yeah, so 7.3-ish, the mass, and we find that by taking the 917 kilograms and multiplying that by the 8 centimeters cubed, sorry. So yeah, 917 kilograms per meters cubed times the 8 centimeters cubed gives us that weight of about 7.3. Yeah. And then we use the Archimedes principle to help us with the buoyant force. Yeah. So we have volume equals the 7.3 centimeters cubed. And then to find the level of the ethyl alcohol that we need, We'll divide that 7.3, or actually 7.34-ish, 7.34, divided by 2 squared centimeters. So if we do that, so it's about 1.83-ish centimeters, which is like 18.3 millimeters. But to find the alcohol, the amount of the alcohol that's needed, we'll just subtract that from 20 to find that amount that's needed. So the thickness of the ethyl alcohol should be like 1.66 millimeters to make sure the ice cube is flushed with it. And the last question, about identifying the unknown metal. This took me a while. I'll be really quick as I can. So it gives us a lot of information just in the question. So the volume is 1 cubic inch, which I've got mass of 117 grams. And then it tells you it's heated to 97 degrees Celsius. And comes to a max temperature of 27 degrees Celsius. And it tells us that the calorimeter has an aluminum cup with its mass and 130 grams of water. And it tells us that the initial temperature of the aluminum and water is 22 degrees Celsius. So just to start, okay, so you've got the volume, just 1 cubic inch of volume. So that's like 16.37 centimeters cubed. 387, sorry. And then we can use that density equation, the P equals the heart. So P equals mass over volume. And that will divide 117 grams divided by 16.387. So that's about 7.14-ish grams per centimeter cubed. So that's part of the problem that we need. And then it gives us the specific, well, does it give us the specific heat of, let's see, of the aluminum, just like 900 joules per kilogram in Celsius. And then water's 4,180 joules per kilogram in Celsius. So we'll multiply 0.117 Celsius minus 27, and we'll set that equal to, what do I set this equal to? Okay, so we'll times the 900 specific heat of aluminum by 0.1, and then we'll add that to 0.13 times that specific heat of water. I think there's something else I need to do. I can't remember, hang on. Okay, and then we have that initial temperature of 22. Okay, so it gave us it was heated to 97 degrees Celsius, final temperature of 27 degrees Celsius. So okay, so on the left side, we'll multiply 97 minus 27 times the 0.117. And then on the right, I already said all that, but it needs to be multiplied by the 27 minus 22. So if we're solving for C, just real quick, so 0.1, nope. Times so that's about 386.7. So about 387. And that specific heat is unique to zinc, I think. So it should be zinc is the metal that we're looking for. Zinc. Okay, and that's it.